But as already we have discussed, polymorphism is nothing but having multiple forms. The object having multiple forms is called as a polymorphism. And already we have seen how to achieve the polymorphism, like a compile time polymorphism and dynamic polymorphism. And we also seen like how to achieve the compile time polymorphism. We achieve the compile time polymorphism through a concept called as method overloading. Today we'll see the second type of polymorphism here. This is a dynamic polymorphism or runtime polymorphism, right? So very important topic, and so it's almost all our concepts whatever you discuss in Java are related to this concept. Every concept in Java related to this concept. Very important, right? So concentrate here. So this concept is related to inheritance. So whenever you are going for inheritance, right? Whenever we go for inheritance, nothing but whenever you have some common classes. Let me take some common classes to discuss this. Now I am having some common classes like this. For again, easy example I'm taking, very small example I'm taking. Yeah. So today I'm taking the classes like this. Right. Now I'm going to define some kind of animals. Cat. Dog and right. I'm defining cat and some animals here. No, because so whenever we have such kind of whenever you define your classes like this, whenever your classes are having some common things in between them, so instead of writing those common things repeatedly, we'll be going for placing all these common things into one separate class, right? And that class we are calling as what? A superclass. That class we are calling as a superclass, right? Now I'm going to make a superclass out of this, right? Because I'm thinking like there are some common methods in between all these animals. So instead of writing them into each and every class, so those common methods I will be placing into different those common methods I'm placing into a different class called as animal class, right? So this is what we have seen in inheritance. So whenever you have some common things, instead of writing them repeatedly, we'll be placing them into a class called as some superclass, and this is my superclass here I have. It's fine. Now my method is like this in the superclass. Whatever the method I'm going to write, the method is like this, which has a meaning. So the method will be writing like this. Assume that I'm going to write a method according to my scenario. Public void. I'm taking a method called as eat method, and the implementation of this method is like this. The implementation of this method is like this, right? So I am going to implement this method system data out dot println of sot sout of now according to my requirement I have written eats something. Example, simple example I have taken. So eats meat. So that is the meaning here. Now this is the common method I have in all these objects and I have implemented it. So all these child classes can access this method. So cat object, through cat object I can call this method, through dog object I can call this method, through tiger object I can call this method. Okay. Okay. Right. So instead of writing this method with three different classes, three different uh, times, I am taking only one copy of this. I have placed it into animal class, and I am making use this. This method can be used with all these objects, right? Okay, fine. Now let me add one more method, such kind of method, right? So I am adding one more method called as public void. The method name is run. The method name is run here. Just again one more method, common method for all these objects is out, right? So system dot out dot println. Now I'm writing a statement, a simple runs with 4 legs, right, guys? No, here. Is it okay? It's not. So just I have written some implementations for these classes. these methods, and these are the two methods which I'm placing inside a class called as animal class, and these two methods can be called through the objects of its child classes. These are the two methods I have in animal class, and these two methods can be called through its child objects, right? Okay, is it okay? Very simple inheritance. So cat C is equal to new cat, C dot eat I can call, C dot run I can call, dog D is equal to new dog, D dot eat and D dot run I can call. Some in the same way I can call these two methods with all objects. Okay, fine. As we discussed, whenever you have these common methods, and in the future your architecture can also be extended, right? Now I'm going to extend this architecture by adding some classes into this. Now the architecture is like this. I'm going to add some classes into this architecture. Now because one more class I required with the same kind of methods, which has same kind of methods, actions. Now this object is like this. Observe this object here. Now when I am adding a new object to this hierarchy, now I have added like this. My hierarchy is like this now. Now through this is becomes a child object because this is also an animal which has a eat behavior as well as which has run behavior. It's fine. It's fine, right? So this is a goat. So goat G is equal to new goat. G dot eat and goat G dot run. It's fine. But there is something I feel like there is something is went wrong here. What is that? What happened here? What happens with this goat object? Which falls in different category. It is also an animal with two behaviors, common behaviors. Right? Goat is also having eat and goat is also having run. And because of each and every animal is having these behaviors, I am trying to implement them in the super class instead of writing them in each and every class. This is what inheritance. And I am extending. So when I designed my class here, the point here into C is when I started designing my class, right? I have designed this super class, right? This super class. I have designed this super class. In focus of these three classes only. Now according to this is fine. And in the future what happened is because some other object is there with the same kind of properties, behaviors. So I have added this. This is a newly added. But is it correct? Is it correct? Is this right or is this wrong? Or if it is correct, how it is correct? If it is wrong, how it is wrong? No. Somebody says no. Why no? It's correct. Somebody says correct. Somebody says no. So why correct? Why not correct? So first we ask why it is not correct. Okay, goat not eat meat. So don't see the statement wise. So not eat meat means what? This statement, whatever I have written. So what is the problem here? The problem with the implementation, but not the problem with the definition. So you wanted to say the method, eat method is there with goat, right? But the implementation, whatever I have for this eat is not correct. Is it? Is it the meaning? So somebody is saying goat will also have a method called as what? Eat. There is no doubt about it. But whatever the implementation is there for this goat is not correct. That is your answer. So there is a problem with the implementation, not with the method definition, right? Method definition means what? This is method definition and this is method implementation. So you wanted to say that there is no problem with the definition. There is a problem with what? The implementation of this method. So this is one which is you are feeling this is wrong. Then what a subclass has to do then? My question is it wrong thing to extend this class here? Is it wrong thing to extend this goat class from animal class? Is it wrong to do that? Extending a goat class from animal class. Is it wrong? No, it is correct. Then there is a problem with this goat class. What is the problem you have with this goat class then? Imagine that some programmer has already created a class for me. Now instead of repeatedly writing these things, now I want to use that functionalities from that class. So that I brought it here. I have extended this class and I want to make use of them. That's fine. This class contains, now whatever the class which I am extending, right? Whatever the class which I am extending, this class contains, let's suppose, imagine there are 10 methods. Right? So somebody has created a class for me and it has 10 methods and I don't want to repeatedly write them because already the functionalities are there. I want to reuse them. So I have created a child class for this. It's fine. But out of 10 methods, 9 methods I can directly use. Directly use means what? The implementation of these 9 methods is okay, fine. But one method is not correct for me. I want to use that method, but still it is not correctly implemented. What is the meaning of not correct means? The implementation part of that method is not correct according to my class. So what should I do here? So what is the problem here? So in this example, what is the problem? Whatever the example I have taken, what is the problem in this example? Is the problem with animal class or is the problem with goat class? Which class has, what is the problem in this? Eat method itself is the problem. Right? So my view is eat method is not the problem. The method is correct. It is there. This behavior is there with goat. But the problem is this implementation. Whatever the code I have written inside this is not correct for what? The goat. And what is the advantage? Shall I remove this method then? No, you cannot do this because this is correct implementation for these 3 objects. So this is not correct implementation for goat. So I want to have a class instead of repeatedly writing eat and run method. Because they are already there in one class, I want to create a child class for it. But this run method is correct. It is absolutely correct for my goat object, but this is wrong. Method is not wrong. It is there. For a goat object, it is there, but the implementation is not wrong, not correct here. So what a goat class can do here, what this class can do here, right? So this is a very key point here because the problem is not with the method goat will have eat, but the problem with what? Its implementation is the problem. So whenever you are creating a child class, from a super class, because super classes means what? They are already created, and because you want instead of writing your own functionality, there is already a class that exists for you. You want to make use of them instead of repeatedly writing. So but sometimes what happens is, whenever the method you want to use, you cannot use all the methods sometimes, right? So it is fine, I can use this method as it is without changing it, but this method I cannot use as it is, because this method is there, but this method is not correctly implemented for this class. It is correct for a few classes, but it is not correct for all classes here. So the class which is not the class for the, right? So to the class which is not correctly implemented, the method which is not correctly the class, whenever you create a subclass, if you feel that the method which is not correctly implemented for this class subclass, so subclass can, what can it can do here, the subclass can re-implement it, the subclass can re-implement it. So this re-implementation we call as what, generally we call it as dynamic polymorphism. Same concept here. So we have seen like a method overloading. When you talk about method overloading, so we have seen the same method is having multiple different functionalities. Like we have taken the example like search student, table kind of examples we have seen, add method we have seen. So the same method with different implementations, and these different implementations we got with the different inputs, listening behavior. That is what we try to understand the day, right? So same method, different implementations, and these implementations will be different from what, the input which we pass, listening, home and all. But this is a different scenario here. The method is same, including the parameters are same, though everything is same, but the implementation will be different. But to achieve this, you will always come across what, inheritance. So what is the problem here? So goat class, whatever the goat animal goat class I'm taking, this animal, this goat is also having an eat. This is fine. This is there. This action is there. But the implementation for this is not correct. So what a goat class can do here? So goat class can re-implement it. So what a goat class can do here? Re-implement. What is the meaning of re-implementation here? There is a very important most key point here. What is the meaning of re-implementation? Right? So what a goat class has a flexibility or facility to re-implement this method. What is the meaning of re-implementing this method? Right? So because method definition is correct, but the method implementation is not correct. The logic inside the method is not correct from the goat point of view. So a goat class can write its own implementation for what? The same method. The goat class can write its own implementation for the same method. Now something eats grass. Right? So what is this now? Right. Now like this you have here. So now if you see this, as we have discussed, having multiple forms. So if you see from the goat object point of view, right? So there are two eat methods. In its own class it is having one eat method, and in the super class also it is having one eat method. So as we discussed, a child object can call a super class methods as well as its own methods. Now there are two different forms you have for the same eat method. There are two different forms you have for the same eat method here. Right? So what are the two different forms and how they can be differentiated here? What are the differences you have here? Right? So the implementation point of view, that there is a eat method and it has two different implementations. One is in the goat class, one is in the animal class. Now if you see from the goat object point of view, there are two eat methods for the goat. Right? So here this is called as polymorphism here, and whenever you achieve, this is what, one more type of polymorphism. What is this one more type of polymorphism? Same method having multiple different implementations. Now here also eat method is having different implementations, right? But the scenario you need to understand here. The scenario is different scenario and different situation we come across this one. Whenever we talk about the overloading, that can be achieved in the same class, right? Listening. As a person I have different behaviors. Listening, the listening behavior I can achieve in multiple different ways. But here, whenever you have inheritance, whenever you go for inheritance, by placing all common methods into one area, one class, and whenever a child class is trying to access these common methods, always the implementation in the super class may not be correct for what? Child class point of view. In that scenario, the child class can re-implement the method. So this re-implementation is called as dynamic polymorphism, and the concept we call as, right, the concept we call as somebody said, it is called as method overriding. What it is called as? Overriding. What is the meaning of overriding? It's a very important mechanism we come across. The first thing you need to understand here is, to achieve method overriding you require inheritance. Without inheritance you cannot achieve it, because whenever you have the methods, whenever you have the methods inside a superclass, and whenever a child class, whenever you want to access these methods through child class object, if the method in the superclass is not correctly implemented, if the method is not correctly implemented from the child class point of view, the child class can re-implement it. The child class can re-implement it. So this re-implementation we call as what? Method overriding. So if you don't have inheritance, there is no method overriding. Blind point and very important point. Method overriding will be achieved in inheritance only. But overloading, to do overloading, no inheritance is required. No inheritance is required in overloading. Right? So very important interview point of view question, overloading and overriding. And I can say without these questions your interview will not be completed. Definitely. Right? So here, this is a special scenario you have here. So whenever you have a common method, whatever the common method we are talking here, and this common method, whenever I place a common method inside a superclass, in the future, this method may correct for what? Some implementations it may not correct for some implementation. Let's suppose, for example, I am going to implement one more class from this. I want to take one more class out of, I want to make one more class from this same architecture, right? So that class is, let's suppose, I want to make one more class out of this architecture as child class. Now that class is what? I'm taking a class called as a lion class. What is this class? A lion class. Right, fine. Now, no need of any implementation in the lion class, because these two are very fine with the lion. Now if I keep, you cannot guarantee that nobody can extend it. Absolutely. These common case methods can be extended by any programmer or any scenario here, because if he feels these methods are there. And if I take one more class, let's see here what this class is. Let's suppose I'm trying to write a class called as a simple class again, right? And this class is like this here, and a class called as a cow class. It's fine. Now is it correct for this cow point of view? No. This method, one method may be correct, but this eat method is there with cow also. Cow object is also having eat, but the problem is implementation. So now cow object can also what? Cow class can also re-implement it. So re-implementation means what? What is the meaning of re-implementation? Why I am going for re-implementation? Because the implementation which is there in the superclass is not correct. There is a reason why I am going for re-implementation. That is the reason why I am going for what? Re-implementation. Right? So whenever I want to re-implement this, so what is the syntactical rules I have here? What syntactical rules I have here? What is the meaning of overriding? So this is called as dynamic polymorphism. And what syntactical rules I have when I want to go for dynamic polymorphism or method overriding? Right? So what is the problem then? What is the syntactical rules I have here? First rule I am saying is, this is achieved in inheritance only. If there is no inheritance, you cannot achieve this. That is the first rule you have. Still, what syntactical rules you have here? Come on. No, I am talking about syntactical rules. We have some syntactical rules when we have seen overloading. Right? So the same behavior having multiple different implementations. So what syntactical rules you have here is, right? So here this is quite different from overloading. So both are having method name should be same, because the same action I am talking about, same action. So that means method name should be same 100%. But different implementations. The problem with what? The same method can have what? Different implementations. When we talk about different implementations, right? So here these different implementations are different here. Not only method name should be same, not only method name must be same actually, not should here, method name must be same along with what? Everything means what? Arguments and return type, everything should be same here along with arguments and return type should be same, right? Then we call it as what? Overriding. Don't get confused here, along with arguments and return type also must be same. So this is called as what? Overriding. Because if you see, this is very, if I see here cow point of view, here I have drawn one object here. So if you see this point of view of this object, this method is correct. Each method is, syntax is correct, definition is correct, but the implementation is not correct. So I want to change only the implementation. I don't want to change anything, only the body of this method I want to change, right? So that means here, so because I want a different body for this same method inside this class, so why should, so we are not going to change anything apart from this method body. So name must be same method, because whenever you say the same method, multiple different implementations mean what? Method name must always be same, and the arguments list also must be same. Arguments list and the return type also must be same. That is what? Very important, and achieved in super and subclasses, right? So it is achieved in super and subclasses only. You cannot achieve this in the same class. You must have an inheritance relationship, right? So what differences you have between that kind of polymorphism and this polymorphism? That one overloading we have seen, right? In both cases name must be same. In both cases name must be same. One polymorphism requires different number of arguments and it can be achieved in the same class. Overloading, right? Overloading means what? Method name should be same and must be different in arguments. Must be different in arguments, right? And overriding means what? Method name and arguments, return type, everything must be same, right? Trying to understand me. Whether you go for overloading or overriding, the concept is same. Multiple different implementations. There also we have seen multiple different implementations, and here also we'll be coming across multiple different implementations. The scenario where I am getting and when I am getting these multiple different implementations is different. There multiple different implementations I am getting with different arguments, but here I am getting the multiple different implementations with the same arguments, and it is achieved in the superclass and subclass. That one is achieved in the same class, right? Overloading will be achieved in the same class. It's not that always it is required to be done in the same class. It can be that overloading can also be achieved in the super and subclasses, but overriding must be achieved in the inheritance only. Without inheritance you don't see any overriding, right? So did you understand what I'm saying here? What is the meaning of overriding? Overriding is nothing but, in simple, if I put, whenever a superclass method, if you have a superclass and whenever you are re-implementing the superclass method in a child class with providing some different behavior, different implementation, that is called as overriding. Did you understand, guys? What is the meaning of overriding? So in this object, in this complete hierarchy, so this goat object and this cow object, they both have eat method, but the implementation of this eat method is not correct from the point of these classes. So these two classes can re-implement this method. Re-implementing is nothing but changing the implementation only, not the definition. Okay, is it okay? Right? Just think about this. If you have any questions, let me ask. Very important concept, right? If you have any doubts, just you can ask me. Yes, any questions here? Somebody asked like can two subclasses can also be overloaded? I did not get two subclasses means overloading means what here? Now there is overloading of eat method. What is the meaning of overloading of eat method here? So if you have a eat method, now we'll try to write a program here so that we understand through a program, right? Instead of theoretically. So I'm going to write a program, same architecture, whatever I have taken. Public class, animal, right? Now, now I am thinking like a big because I'm making this as a super class because it has common methods. Because there are few animals I'm going to take here, and inside them I have found some common methods instead of writing them repeatedly. So while designing this class, I feel there is one class is required which contains all these methods. So I am going for this. System data or dot println of what? So same method I am taking. Eats meat, right? One more method I'm taking here. Some method, just imagine this is not the correct way, correct example, correct scenario. Its example is okay, when it's not the correct scenario you will get. Just for example, explanation purpose, I'm taking this simple, very simple example. Runs with 4 legs. It's fine. My first superclass is ready. So let me quickly save it. Java, and I would like to save it into the online classes. It's fine, right? Let me quickly create a child class. What is this? Cat extends animal, right? So because these two methods are common, I'm feeling these two methods are common, so I'm not going to implement them. Now apart from these two methods, let's suppose its own specific method I'm adding to this, right? What is this? Some method, cat specific method. This is not exist with all the methods, all objects, right? It's fine. Now my class is cat. Okay, did you understand what I'm trying to do there? I have added one specific method of cat. So this method, this specific method should be called through only cat object. It cannot be called with any other objects. If it is having its child classes, it can. Now one more version of this I am creating, right? That is, instead of dog, I'm taking, instead of cat, I'm taking a dog here. Fine, easy, right? It is a bark. Its own method I'm writing here, dog box. Right? So what is this? Dog has its own specific method and two common methods, eat and run. There are cat and dog both are having two common methods along with their specific methods. So what are the specific methods you have? Right? So its cat's specific method is this one, and dog's specific method is this one, and along with both are having their own common both are having their common methods called as right, eat and run. And where is it? It is animal, right? So this is fine. So this is my classes here. Now let me create a right. No, dog has exactly 3 methods. What are the 3 methods? Each object is having 3 methods, but out of those 3, one is specific, 2 are common. Eat and run are common for both, but bark is specific to dog, and cat is specific, mew is specific to cat, right? So public class, animal main class, yeah, eat and run are common things. That is the reason why I have written them into that class. Public static main method here, void main string args. Now, so I am going to create the two objects here. This is the first object, cat c is equals to new cat. So through cat object, what I can call here? Through cat object, what I can call here? Now I am making a dog object here. Dog d. Through cat, you can call three methods, right? So cat's own method called as mu is its own specific method. This is only called through what? Cat. But it also having two common methods. Eat is the one, and the one more is dot run. The same thing here. So these two methods can be called through cat or dog, right? So d dot bark is the one method I have. It's fine. And apart from this method, it can also call the two common methods. Dot java here. Now let me compile my program and execute it quickly. Right? Java C animal main, fine, compiled, no errors. Java animal main. It's fine, right? So cat, so three methods, and dogs this method. It's fine, right? You cannot call bark on the cat. C dot bark. Cat and dog are not same object, two different objects, but having some common things. It's fine. This is fine. According to this is fine. But what I want to do is, now when I have created these methods, that is fine. When I have created these methods, that is fine. But in the future, some other programmer wants to take the same class, because public class, some goat is creating a class, and which has also, this goat is also having the same methods. Right? So I am not going to override them, but there is a problem here. What is the problem here? So the run method, the eat method is not correct. It is there, eat will be there, the behavior eat is there, but its implementation is not correct from the point of view of goat, right? So this goat class can re-implement it. Public void re-implementation means what? It should have same, everything should same, right? I am going for this implementation because of implementation is wrong, not the method. Method is correct. So system data out dot println of what? Eats grass, something. Try to understand why I am going for this one more implementation of eat in the goat class, right? So very important. So in the child class, rewriting the superclass method. In the child class, rewriting the superclass method with the same method signature, right, is called as overriding. Now we'll create a goat object here in the main class. Right? What is this? In the same way, goat. Now there are two eat methods from the goat point of view. What are the two eat methods? One is from its own class, the other one is from its a super class. Now which one will be called here? Goat and g dot, what is it? Eat. So this goat has two methods, right? But actually two methods means what? One, eat and run. But this eat method has two different versions. One is in the super class, one is in the its own class. Now let's see what it is going to happen here. What it happens here, it's fine. See here, when I call eat method on goat object, what it is giving me? Eats grass. Eats what? Grass. But when I call the same method on cat, it is giving me eats meat. Eats rat and eats meat. Why it is calling? So whenever you call a method, first preference will be given to its own method. So goat object, what is the object I have here? Goat object, and the method is available in the goat object, eat method. So it always calls its own method. If the eat method is not there, then it goes to its super class, and the eat method from animal class will be called. Right? It goes to its super class and eat method from the animal. In the same way, cat object, when what happened to the cat? Because in the cat I don't have any eat method, then this method is called from what? It's superclass. Right? So, but it is not the case with goat, because goat is having its own version of eat method. So this method will be called. If it is not having, then it goes to what? Its superclass. Yeah, suppose in the goat class this eat method is not there, it calls the superclass method, obviously. Now just comment it. Superclass methods can be called through child class objects. But why I am rewriting the eat method? Just the concept you need to understand here. See, goat eats meat. What is this? Eats meat I got twice. One is with cat object, one is with the goat object. This is my main class, right? See, meat I am trying to eat method I am trying to call twice. So twice I got the same, but it is not correct for goat object. So what a goat class can do here, it can re-implement it by providing its own implementation for the same method. This is called as overriding. So when the goat class has its own implementation, now the method from its superclass will not be called. Let's compile it and execute it. See here, eats grass, eats meat. Okay, did you understand why we go for re-implementing the methods when you come across superclass and subclasses? Is it okay? Very important concept, guys. If you have doubts in this, it's very difficult for you to understand the future. From what? Goat? You cannot directly call it. From goat you cannot call it. See, the basic point, actually the basic point you need to understand is why I am writing a eat method in the goat class. Because I don't want to use its superclass method. That is the reason why I am writing this, right? If I want to use the superclass method, why should I rewrite it? I don't require it to rewrite it. I don't want to use the superclass method as it is because it is not correctly implemented. So I'm rewriting it. Rewriting itself is what? Meaning of I don't want to use the superclass version because it is not correctly implemented. I want to have my own version of the same method. That is the reason I am rewriting it. It is possible to call the superclass method. There is one more way is there that already you know that, right? Do you have any questions here, guys, remaining? Yes, very, very important concept. If you have any questions, let me clarify first, then only we move. Always I am getting the questions from only one. What happened to others? I don't understand whether. I will not understand. I cannot read your mind, right? You need to tell me, then only I can. Yeah, how many methods you want to override, you can override. Run method you want to have one more behavior in the goat class, you can have. What is there? You can change. All methods can be overridden. All. Run method also you can re-implement it. If you feel that run method is not correct, then you write it. What is there? Right? Yes, all are correct. Goat can also have its own method, like how cat and dog are having its own methods. Goat can also have its own methods. Absolutely. Right? So this is very important. What about only I'm getting the replace from 2? What about others? Right? So now let's suppose here, now, okay, fine. In the cat class, now I'm going to write one more version of eat method. In the cat class, I'm going to write one more version of eat method, public void eat. Let's suppose, example, something, I'm going to pass eat, now cat eats rat object, I'm passing it. Now, so this eat method and animal class eat method are called as overridden. Right, the method from the animal class is called as generally in the context of animal and goat overridden method, overridden, and in the goat class method is called as overriding. It is overriding that method. Now in the context of animal and cat is the same story. Are these called as overriding methods. These two methods, animal and cats eat method is overriding. Right? So it is not overriding, guys. It is not overriding, it is overloading only. Why? Because there is a different implementation absolutely for eat method. There is a different implementation I have for eat method, but this is different implementation I am doing with the different arguments. Whenever you have a different implementation with the different arguments, it is called as overloading, not overriding. Overriding requires everything same. Right now this overloading. Did you understand? This eat method from animal class and this class, this cat class is not overriding, it is overloaded. So in any case, the concept is the method is having multiple forms, and the multiple forms can be with the different number of arguments, or multiple forms can be with the same number of arguments. This object data type I am passing. There's a one type of data type. Don't think it's a that class object. Yep, that is the class. I need to create a class, I need to pass that object. Right, so this is one more special scenario we have come across, and a very important scenario. This is the one. Right? Yeah, that class separately you need to create. Right? So this is a very special scenario you have, and we always come through this when you have superclass, subclass. Now let me ask one question. Again, one more important question, right? We have seen overloading with methods as well as we have seen overloading with constructors. The same way, can I override the constructors? We have seen overriding the method is possible. Overriding the methods are possible, but is it possible to override a constructor? One more important interview point of question. Right? So constructor overriding is not possible. Overriding with the constructors is not possible. General case is like a name should be same. It's not possible to have the same name for the two different classes. How can you have? Right? Goat class constructor will be writing with goat name, and animal class constructor will be writing with animal name. Right? So constructor overriding is not possible, and the most important thing is, so this overloading and overriding concepts are applicable for only methods, not for variables. A class can have what? Instance variables as well as instance methods. Right? Yep. Constructors can be only overloaded. So class will have instance variables and instance methods. And overloading and overriding are the concepts are applicable for only methods, not for variables. You cannot say a class property is overridden or overloaded. A field will have only one value, right? And so fields will not participate any overloading and overriding things. Now here, so actually this is what we have, different forms here. These are very important. Now this concept leads to lots of other concepts. Carefully understand. This is the concept. The dynamic polymorphism leads to other concepts. Okay? It's a very important concept. If you have any doubts, clarify here itself. Now whatever the concept you learn from here, all are related to dynamic polymorphism. Every concept related to dynamic polymorphism. Exceptions, collections, inheritance are like exceptions, collections, threads, IO packages, everything is dynamic polymorphism only. Okay, fine, right? So now we try to understand one more concept called as very important concept here. This is also, now I am going to write a statement. Superclass reference variable can refer to a child class object. What is the meaning of this? It makes a very important statement. Remember this statement, superclass reference variable can refer to child class object. Very most important. 10 stars, right? So what does it mean here? Right, see here, I am talking about, if you see this diagram, we are talking about, so here, goat object, cat object, dog object. How many forms goat object is having? Now if you see this diagram, so goat object is having two different forms. What are the two different forms? Goat object is of type goat. Goat object is of type goat, as well as goat object can be of type what? Animal also. Right? So goat is a goat as well as goat is also an animal. Two different types you have. Cat is a cat as well as it is also animal. But what about animal? Animal is animal. Animal cannot be a goat, cannot be a cat, cannot be a dog. You cannot say reversely. So goat can be said as what? Goat is a goat. In the same way, goat is also said as what? Animal. So there are two forms. Each and every object, whatever you see in this diagram, has two different forms. One is its own form and one is it's a super class form, animal. So goat is a goat. So what is the meaning of how we write this statement programmatically? If you see this, this is what is the mean. Goat is the object and its type is what? Its type is goat. Dog is the object and its type is what? Dog. Cat is the object, its type is what? Cat. Not only this, you have one more type for goat object or cat object or dog object. What is it? New goat. What is the object I am trying to create here? Goat. And what is its type here? Now up to now, whatever the programs we have written, always we will be taking what? Whatever the object you create, we will be referring this object by using its own class. But this is a different scenario. Whenever you have inheritance, so the child class object can be referred by using its superclass variable also. It's a very important thing. So again, inheritance. Whenever you have a superclass and subclasses, now here see this, what is this? Goat object. If you see these statements carefully, observe these statements. Object is a goat and its type is what? Goat. Here object is goat but its type is what? Animal. So what does it mean here? Subclass object can be referred by a superclass variable. Like this, not only goat. This A can refer to what? A can also refer to new dog. I can say what? Or A can also refer to what? New cat. Because animal can be anyone. Animal can be goat or any form. Right? So it is a variable, it is a object. Now in simple you can remember. Now always as we discussed, this assignment operator works from right to left. Goat is a animal. What is it? In simple you can remember, goat is a animal. Dog is a animal. Cat is a animal. Two things. Cat is a cat. In the same way cat is also an animal. Dog is a dog as well as dog is a animal. And goat is a goat. The same way it can also be animal. But reverse it is not correct. What is the meaning of reverse it is not correct? What I cannot say. Animal is not a new animal. It is not correct. Animal is a cat. Can you say this? What I am saying? Animal is a cat. Can I say this? Animal is a cat. Is it correct? Animal is a cat. Can I say this statement? More general statement again. Is it correct? Animal is a cat. Can I write like this? No, we cannot do this. Why? Because animal can be. Animal can be in the form of you cannot say animal. How can you say animal is always a cat? It can be what? Goat or something. You cannot say. But 100% I can guarantee that a goat is an animal. Dog is an animal. Cat is an animal. So technically speaking here, superclass reference can point to what? All child objects. So here animal can be used. How animal class can be referred to what? How many objects here? Animal class reference can be given to how many objects? is equals to its own object. Animal can be used for its own object, or animal can be used for what? Goat object, or animal can be used with what? Right? Dog object or animal reference can be used with all its child classes. If it is having 100 child classes, all 100 child classes can be called. Right? Animal is a animal, is same as goat is a animal, dog is a animal, cat is also animal. All are animals. So this is a very important statement. Superclass reference can point to a child class object. This is a very straightforward mechanism what we are using since this day. Now this is what different here you have. Right? So very important mechanism. Very important mechanism. This concept leads to you one more concept called as, this is where the actual concept of this is the where the actual beauty of overriding comes into picture, right? Now here see this, right? Now I'm going to write like this. So I think you understood what is the meaning of a superclass reference and child class object. Did you understand? I think. Okay, shall we continue? Okay guys, yeah. Now just observe these statements, forget about these things. These are very straightforward now. Now through this A1 is a variable, so try to understand. A1 is a variable of type animal, but it is having a object goat. It is also almost, it is not exactly, this is 100%, huge difference is there between this one. So as we discussed when we discussed initial classes, we have discussed like this. When we discussed initial classes, we have discussed it like this. You can compare this topic with this. 10 is the data, and this 10 can be 10 can be in the form of what? Byte. 10 can be in the form of what? Short. 10 can be in the form of what? The int. 10 can be in the form of what? Long. Like this. This same 10 can be having multiple different forms. You cannot relate it, but in simple I am saying. In the same way, a goat object can be in the form of what? Goat. And goat object can be in the form of what? Animal also. Same, the data and its types. Here also, the data means what? New goat. New goat becomes what? The data, object. And what? Its types. It has two different types. What are the two different types you can have for this? One is its own type, and one is its superclass type. Right? This is the meaning of this. So this is actually a polymorphism mean. An object is having multiple different forms is called as what? Polymorphic object. Now goat is the object which is having two different forms, animal form and goat form. Okay? If you want to remember this very simply, this is how you can remember by comparing. Right? But there are some things need to be taken care here. Through this A1 what I can call here. Through this A1 what I can call. I have a eat method. Now I am trying to call eat method. Now what I am going to get here? A1 dot eat. What I am going to get? Now my classes are like this. Before that, this is my goat class, which has its own eat method, and I have a superclass called as animal. In this also have a eat method. This is one class. This is one more class. This eat method is having its own implementation in the goat, and the same it's in the animal it has its own implementation. I am calling what? A1 is of type animal, and this A1 is having a pointing, it is having a object and that object is goat. Now A1 dot it, what happens here? When I call A1 dot it, what happens here? Right? You will get absolutely correct answer. You will get the method will be executed from what? See here, eats grass. Why I got this? Eats grass. Why I got this? Because the object is what? Goat object. No. Object you need to see. Object is what? Absolutely, that is also one point here. Its own. Object is what? Goat. And it will always, preference will be given to what? Eat method of what? Goat. Right? Now to the same variable I am going to assign new cat. Now to the same variable I am assigning what? New cat. What happens here? A1 is equal to new cat. Is it correct? A variable can be initialized multiple times. I am reinitializing the A1 with what? Cat. Is it correct? Yes. Now I am going to call A1 dot eat. A1 dot eat. Now what happens here now? Eats meat from a animal class. Right? Because cat is not having any eat. It is called from animal class. Again same thing I am going to do here. A1 is equals to what object I can still take here? New dog. Right? And A1 dot what? Eat. Now what happens here? Eats meat. Fine. So let me run this program first so that I will modify the program. Eats grass for what? Goat dot eat. Eats meat for cat dot eat and eats meat for dog dot eat. Now I am going to change my classes here. My cat class I am going to change here. I would like to write one more version of eat method for cat separately. Eat eats rats. Again in the same way I would like to have one more version of eat method in the dog class. Okay, we'll have like this only. Now what happens? I'm not going to add any method to the dog class. Now what happens in this case? If I compile and execute, see the methods and give me the answer. First one is grass. Okay, fine. When you call this eat method on goat, second one is rat, third one is meat. Right? So here this A1 dot eat will give you eats grass. This A1 dot eat will give you eats rat. This A1 dot eat will give you meat. Right? Eats grass, eats rat, eats meat again. Now very interesting point here is, this is not simple. Very interesting point here is, see this. 1. What is the statement? A1 dot eat. What is the statement? A1 dot eat. What is the statement? A1 dot eat. Everywhere I have what? A1 dot eat, A1 dot eat, A1 dot eat. Right? Right or wrong? Yes. But these three A1 dot eat, same statement giving me what? Three different outputs. One is giving me eats grass. One is giving me eats what? Rat. One is giving me eats meat. Yes. The same statement is giving me three different outputs. Dynamic method dispatch. This is the reason why it is called as dynamic polymorphism. The method calls will be dynamically dispatched. You don't know which method will be called and from which class the method will be called. You don't know. This is called as dynamic method dispatch. And very important point to be noted here. Okay, can I call A1 dot bark? What does the bark mean here? Now A1 is having what? A1 is having eat dog here. A1 is pointing to dog object. And on the dog object, when I call eat method, it is getting called. Because this method is not there in the dog, it is getting called from its superclass. Now can I call this bark here? A1 dot bark. Bark is a method there, right? Bark is a method is inside what? Dog class. I have a bark method, right? In the dog class I have a bark method. Now can I call bark here? It's the most important key point. Today's discussion, whatever the discussion we have, this is the key point to this discussion. Yes or no? I am able to call eat method, right? Or for if you want to simplify this, so A1 dot eat. Now this is what? This is cat object and A1 dot eat is called from what? Cat class. Now A1 dot what is that method? Right? So if you want to see the cat class, you can see here. What is the cat class you have here? See here. New and eat. Two methods are there in the cat class. Right? and you have seen what each rat is getting executed for you. You can see on the screen. Now in the same way I'm trying to call mu method of the cat. Is it executes? If it is executes, what happens? Come on guys, say yes or no. That's it. Now eat method and mu method. I'm trying to call these two methods from A1, and new cat is there in the A1. Yes or no, right? So very important point as I'm saying, right? So you cannot call mu method. You cannot call bark method. See, your compiler will not allow you to do this. Who is stopping you? The compiler itself is stopping you. The program will not be compiled. A1.mu you cannot call, A1.bark you cannot call. No. No, it's not possible to call these two methods. Right? So very important point, remember this, why it is not correct, possible. Just you identify it, you research on this, very important point that is to know. Right? Whenever you have a superclass reference and child class object, whenever you have a superclass reference and child class object, through this reference, you can only refer to the methods which are there in the superclass. You can refer to the only methods which are there in the superclass. So eat method is there in the superclass, that is the reason I am able to call. And run method I can call because it is also there in the superclass. But you cannot call child class specific methods through superclass reference. Getting me? You cannot call child class specific methods through superclass reference. Absolutely not possible. Whenever you have a superclass reference subclass object, you can call only, you can refer only methods. You can refer the methods which are there in the superclass, but you cannot refer to the methods which are there in the child class specific methods. Child class specific methods you cannot refer. Absolutely not possible, because this mu is a child class specific method, you cannot call it, and this bark is also a child class specific method, you cannot call it. But this eat method is there. This is a common method from what? Animal class, you can call this. I am not talking the execution output point of view, I am talking calling. So this eat method is from animal class, you can call it. Right? A1 is of type what? A1 is of type animal. Right? So that when A1 is of type animal, so that through this A1 you can call the methods from animal only. But execution is different. Execution will be on based on object. If the object is goat, the method will be executed from goat. If the object is cat, the method will be executed from cat. If the object is dog, the method will be executed from dog. But to call it, the method should be present in animal, because A1 is of type animal. So you can call only, on the A1 you can call only two methods. What are the two methods you can call? Eat and run. You cannot call these two methods. Why? Because these are not there in A1. Getting me? Very important point. So by using superclass reference variable, you can call, you can refer only superclass methods. You cannot refer child class specific methods. But the method call can be different. The method call can be child class also, because the method calls will be depends on the object type. This is the object, this is the reference. Okay. Through A1 you can refer to the only methods in A1 in animal class. You cannot refer to the methods which are specific to what? Cat or dog. Okay. So try to research on this point. Very, very important point, interesting point. If you have any doubts, right? If you have any doubts, so that we can clarify it. This is the most important topic, guys. Otherwise, I would like to stop the session today with this. Right? We try to understand method overriding, dynamic polymorphism, and we try to understand superclass reference, child class object. At the same time, we try to understand dynamic method dispatch. What is the meaning of dynamic method dispatch? the same method call, the same statement is dispatching to different method calls. This is executing the statement from goat class, this is executing the statement from cat class, this is executing the statement from animal class. Dynamically methods are dispatched at runtime. The methods will be dispatched at runtime, not at compile time. The reason why this is called as dynamic method dispatch. All these concepts are again related to inheritance. When you have inheritance, you will come across a concept called as overriding. When you have a overriding, you will come across a concept called as superclass reference subclass object, and dynamic method dispatch is also related to the same, right? So shall I stop the session then?